Hello, in this video I'm going to answer a question that students ask about problem number 14, homework 5.2. Consider the following function. Find the open intervals on which the function is increasing or decreasing. So these all are related to section 3.1 and 3.3. In 3.1 section, we need to recall a definition of a critical number. Let's make sure that we understand that the critical numbers are those in which function is defined, which means function has its value. And then we differentiate the function and either find all numbers for which derivative is 0 or derivative does not exist, which means f is not differentiable. So let's look at the function we have. In this case, we can see that all real numbers except of 0 in the domain of this function. So if I write the domain of this function in domain D, let me go ahead and do it. So if I write the domain of this function, domain in set notation, I can say all real numbers not equal to 0. So if we look at this in an interval notation, it will be negative infinity 0 and 0 positive infinity. So we need to find the critical numbers. So the critical numbers. For that, we need to find the derivative. So let's differentiate. So I'm going to use the quotient rule. Also, you could use alternative method, just divide x squared into each term and do that way. So the quotient rule with square denominator, that will be x to the fourth. And we find the derivative of numerator, which is 1, multiplied by denominator x squared, subtract numerator as it is, x plus 2, multiplied by the derivative of denominator, derivative of x squared is 2x. Open parentheses, combine like terms, you get x squared, subtract 2x squared, subtract 4x over x to the fourth degree, and combine like terms. As you can see here, we have a situation with the like terms. So now we're going to say it will be negative x squared minus 4x in numerator over x to the fourth. And it's easy to take, since it's just happened like so in this case, this negative sign we take outside and put here negative, and here we have x squared plus 4x over x to the fourth. Now what we need to do next to find the critical numbers. F prime equals 0, so we need to solve this equation, equals 0. Or f is not differentiable, but since 0 is not in the domain of the function, as you can see here, it's not in the domain. We don't need to look at the 0 here as f is not differentiable, because f is not defined at 0, so we will take care of 0 later. So to solve this equation, we have a fraction equals to 0. You know, any fraction equals to 0 when its numerator 0 and denominator is not 0. So we're solving x squared plus 4x equals 0. That's numerator equals 0. We factor out x and we have x plus 4. And the solution of this equation is x equals 0 and x equals negative 4. X equals negative 4 from the second parenthesis. From the parenthesis, it's only one pair of parentheses. So now x equals 0 is not a critical number. Please understand why. Again, I remind, because f is not defined at 0. x equals -4 is a critical number. Now I would refer you to example 4 in the ebook. This example shows you how and why we need to consider still 0, because 0, as we can see, is a point of where function has an asymptote. So we're going to look for the intervals of increasing decreasing. This is what I found in the book as well. The derivative is related to the slope of a function, so if derivative is negative, that means the function goes, the slope of the tangent line goes down, or we can say the function is decreasing. If derivative is 0, that means that the slope of a tangent line is 0. That means we have a horizontal line. And if derivative of the function is positive, then the function is going up and it's increasing. So we need to analyze the sign of derivative. For the intervals divided, I'm trying to fit everything in this on this page so we can keep looking at what we have. So here we have intervals, so we need to include -4. So we have, I would suggest you to have a number line like so, put here -infinity, positive infinity, put numbers at which function is not defined, so there will be 0, empty because it's not defined, and then we put number -4 where it belongs. At -4 it's defined, but we're still looking for open intervals, so it said open intervals. So basically, in order not to forget that -4 must be following or preceding by parentheses, we have to, depends which side you use. So we will look at this interval on the left, the interval in the middle, and interval on your right hand side. So we can put these intervals in a table, and this all again will explain in example 4, section 3.3. You're welcome to use your ebook and go to that example. I will do it for you. So the first interval is x between -infinity and -4. So let's see what sign of derivative we have here. And the second interval, as you can see, between -4 and 0. And then we get another interval 0, positive infinity. We need to test the sign of derivative. So let's look at the derivative after we took that negative sign. So let's look at this derivative. So this is our final expression for derivative. Again, I'm trying to put everything on one page so you won't be looking at different pages. So you can see, so for this part, we don't need even equal 0, we're just analyzing the signs of derivative on each interval. So what I'm going to do, I'm going to analyze this expression first. So the denominator x to degree forward, 4 is even degree. Denominator always non-negative. It's either 0 for x equals 0, where it's not defined, or positive. So this is positive. So the sign will depend on the sign of numerator and this negative sign, don't forget. So we need to pick a number in this interval. Say x equals any number to the left of -4, say -5, and analyze the sign of derivative. So if you plug in -5, we have -5 squared, 25, plus 4 times -5, which will be a -20. 25 minus 20 is +5, but then this negative sign in front makes derivative negative, so f prime will be negative. So the function will be decreasing on this interval. So the interval will be decreasing, the function decreasing. Remember to refer to the theorem or this rule which I posted for you. So derivative negative, the function decreasing. Now we need to pick a number between -4 and 0. Say -1. You pick a number, you randomly pick a number, just a number that between or belongs to the interval you analyze. So I chose x equals -1 because it's easy to calculate. So if I plug in here again, remember the denominator always positive because it's x to even degree. And it's it now, nothing else here. -1 squared 1 plus 4 times -1. -4. So this portion will be -3 and negative sign makes it positive. So the derivative will be positive. And the function I will show you this sign is increasing. So decreasing will show arrow goes down. Now we need to choose a number between 0 and infinity. Why not to choose 1? It's easy again. 1 squared 1 plus 4 times 1, 4, which is 1 plus 4 is 5, positive. And negative sign, so again we chose 1 and derivative is negative. So derivative is negative, the function is decreasing on this interval. So the answer to this question that f of x is increasing on the interval, it's hard for me to write here today for some reason, increasing on the interval -4, 0. And on other two intervals, the function is decreasing. So I hope it was helpful. Please let me know if you have any other questions. Thank you for your time.